Welcome to the meeting room at Global TV Talk Show, a broadcast service of globalbusinessnews.net.
This episode from the meeting room of Global TV Talk Show is brought to you by
The Bridge School, the accredited international online private school of choice, at bridgek12.org.
Porch Light Rental and Destination Services. Reduce your renter lump sum or managed relocation costs. Visit them at porchlightrental.com.
And by airs.com. With our full range of services, we can help design and manage your international relocation. Find us at airs.com.
Primestone Partners, featuring corporate, government, and developer housing solutions, as well as senior-level advisory services. Find them at primestonepartners.com.
And by International Auto Source. We are the vehicle experts for expats, featuring all major brands of automobiles with flexible solutions and financing. On the web at intlauto.com.
Become a global player in your field.
Cross Culture to Go provides virtual support for your global business and career success.
We can help you thrive in 140 plus countries and markets.
On the web at crossculturetogo.com.
This is Ed Cohen in San Diego, California. You're on Global TV Talk Show. This is a very unique program today. We have a distinguished scientist, Dr. Howard Federoff, has been working on targeting disease research, including Alzheimer's, autism, concussion, depression, epilepsy, multiple sclerosis, Parkinson's, and stroke. Dr. Howard J. Federoff is an expert, a renowned expert, has been the CEO of UCI Health and is now involved in a new venture. Dr. Federoff, what are you into now?
Well, first, Ed, thank you for inviting me. And it's a great pleasure to be contributing here. Currently, I'm the CEO for a publicly traded company that is focusing on the development of cellular gene-edited and gene therapy products, in addition to having a legacy asset that relates to a particular oncologic indication. So I'm building a company. It's exciting. We have a lot in front of us, but I'm delighted to be able to find time to be with you and the rest of your audience.
This is the first show in a series of one a month, deep dives into the world of neurology with scientists like yourself and researchers, doctors in the field of neurology as it relates to, as you can see on the screen, findneuralhelp.org. Mark Colo, welcome to the show. Tell us a little bit, please, about findneuralhelp.org.
Well, thank you, Ed. It's good to be on your show. I've been on your show once or twice before, and I always enjoy these opportunities. Find Neural Help is a 501c3 charity that's committed to helping individuals that contract chronological illnesses, primarily neuro diseases. I've had Parkinson's, as you know, for about 15 years. It brings a certain set of challenges, and oftentimes the highest hurdle to me is just the diagnosis itself. You know, to be told that you have an illness that's going to, gradually take parts of you away, it can be a traumatic experience for an individual. So it impacts so many things. As Howard knows, Parkinson's and Alzheimer's affects almost every cell in the body. Eventually, it's insidious. It continues its forward movement, and all you can do is just hang on and do the best you can. Just keep putting one foot in front of the other. So
yeah, but don't you sort of find compensating balances, if you will? In other words, you go for walks. You think about the man upstairs. You look for guidance with your family. And our friend in Canada, Larry, plays the drums or goes out for 5K runs in order to get that energy in place. Isn't that correct?
Absolutely. You have to do these things to kind of keep your spirits up and keep you moving, pressing forward, and trying to challenge yourself. You know, there's some. I can actually still play golf. I'm really thrilled that I can still swing a golf club, and I play like most players. It's a series of mistakes with a few good shots in between. But I'm thankful to have that as an outlet.
I think I want to play golf with you, because then I know I may not lose as much. I mean, not money, but just points.
Oh yeah, yeah, it's fun.
All right, okay, so Doctor, you've been into this kind of research and for years and years, right?
I have been. I can give you a brief overview of how we got started and where it's led, if that's helpful.
Yes, please. If you could do a couple of minutes, that will bring our audience, who are, once again, they're not scientists or doctors.
Right. So I'm a physician scientist, and after completing all of my clinical training, decided to take on a problem that was a hard problem at the time, which is to try to modify nerve cells when they were either susceptible to damage or they've already been damaged. To make a long story short, we had developed a method whereby new genes could be inserted into those damaged nerve cells. And that led to our first clinical application, which was to take on Parkinson's disease. Succinctly, I found that it was necessary to make a multidisciplinary consortium to go after that. And we brought together basic scientists, clinical scientists, neurosurgeons, neurologists, and others, and developed what was then a consortium supported by the National Institutes of Health to try to bring an idea into clinical trials. And that was a gene therapy for Parkinson's disease.
So does that mean replacing genes or reordering them?
Well, that's a great question. In our case, it wasn't that complicated, but yes, that's certainly possible now, although it's still in its infancy. The approach that we took was to use a very safe vector. It's derived from a virus. It doesn't, when gutted as we did it, it doesn't cause disease, but it allows for the neurosurgical implantation of those viral vectors into the brain, particularly in areas that are affected by Parkinson's. And then once the gene is expressed, which is not a replacement gene, but rather a gene that will provide better support of the cells in Parkinson's, the dopamine neurons that are under duress, so that they could stabilize. And so the goal was to really develop something that could slow the progression of disease, a classical approach to disease modification. But it's not as if we would introduce new genes where there might have been defective genes. That's on the horizon. And, you know, there are a number of things that I think are exciting in that area, but we did not do that. Just very briefly, I became interested in how dopamine neurons normally develop. And then in that context, understood the nature of the proteins that are normally made in the brain, so that one could imagine if those neurons, the dopamine neurons, were beginning to die or otherwise be damaged, we knew that a set of proteins called growth factors could be used to stabilize them. And they could either be delivered, as I've just described, using a gene therapy, but we formed a company some years back to deliver it as a protein therapy. So the basic idea is that you put indwelling hardware into the brain of Parkinson's patients, and then we were able to have a reservoir that was implanted subcutaneously, and then we would pulsatile deliver the growth factor, which is known as GDNF. It stands for glial cell derived neurotrophic factor.
In the liver?
In the brain.
In the brain.
In the brain.
Yeah.
Yeah. So the reservoir is actually right under where your collarbone is. And so you can fill it, periodically as you need to have the drug replaced. And so that completed a phase 2B study. And there now is planning for an extension of that. And the hope is that that approach a protein delivery approach will ultimately make it into what's referred to by the FDA and other regulatory agencies as a registration study. If successful, it would then be a therapy that could be available to Parkinson's patients around the globe.
Isn't that interesting? So I want to bring this up, and you can deflect it or shoot it down or whatever, but I had a show recently with a concert pianist who has been doing some work, not full time, but in music therapy for people with Alzheimer's or Parkinson's, to relaxing them, the music, and when they were shaking or they couldn't walk straight or even get up or couldn't remember who they were or what, this older lady had the headphones on and listening to some music from when she was 20 years old or so, and she started singing along with the therapist. And it was like, whoa, night and day. And then in another instance, there was this elderly gentleman who was really having trouble standing up and walking straight, with the nurse right by his side. And then they put the headphones on, there was some music, and then he started dancing with the nurse in perfect harmony. So
Right.
What is going on there? That's a miracle, isn't it?
Well, I think it's a great example of how we store information within the brain and how we recall it. A little more than a decade ago, I started an initiative called Music in the Mind. And the idea was to try to best leverage in the setting of progressive degenerative neurologic disease, the circuits that are still active and that can bring back information that can be brought to the fore, either as a memory or in some cases, the ability to, if you will, execute a motor movement that you learned so long ago, like a dance. And so the storage of that information is intriguing because sometimes it is among the most distal things that are damaged by progressive neurologic diseases. And therefore, since they're intact, it's really a question of how do you reactivate them? How do you bring them to the fore? How do you demonstrate that something that had been deeply remembered sometimes many decades ago can actually be activated? The other part of this, which I think is quite extraordinary, and I don't know whether your guest talked about it, but there's now a lot of evidence that suggests that physical movement, including program movements such as dance, actually stimulates the brain. And interestingly, bringing it back to the comment I made earlier about growth factors or GDNF, in the stimulation of those circuits, one of the things that's really interesting is that when one cell talks to the other, the way that they get on the same wavelength is that the cell that is being called actually releases a growth factor. And so if you train the brain and you take advantage of those circuits that are still in residence and you activate them, you actually not only restore those remembered motor movements or informational vignettes from an earlier time, but you're actually promoting the plasticity in a way that reinforces the continued use of them. So we talk about use-dependent plasticity. And in Parkinson's, there's a number of programs that have been demonstrated to produce clinical benefit. One of them, for example, is dance. Another is yoga. There is also now an interest in boxing, not really trying to make pugilists out of patients who have Parkinson's, but the motor movements that are involved in actually the cascading from left to right, improve balance, front and back, improve balance. And it's in those contact points, which are light during the sort of training, that you actually can reinforce some of the circuits in a way that you wouldn't normally do just in your daily life. So we're learning a lot about how to use alternative methods to sustain, reinforce, and maybe on occasion make more powerful those residual circuits. And I think that music, I think movement, you talked about Mark doing walks. It's a great thing to do. Oftentimes it's the repetitive movement that gets into a cadence and it actually frees the mind. So you can actually think about things without having to think about, well, I need to press the button to cross the street. So you're sort of in this moment where the historical instructive way you've learned to walk is being reactivated. You're doing good things in walking because you're using energy and you're actually creating some plasticity. But at the same time, I've always found, whether you're a Parkinson's patient or other, is you're actually liberating the brain to pay attention to other things that sometimes are very important. And you don't get to do unless you have that other piece sort of in motion, as it would be when taking a walk.
Wow, thank you for that explanation. I think I followed most of that. Scott, what do you think of all that?
Well, I think it's pretty incredible. Doctor, I had a question. If you are FDA approved with what's pending, what does a Parkinson's patient have to hope for with what you've got and if it is approved?
Yeah, so the first thing is that it's worthwhile, and the Parkinson's community has been engaged with this. The clinical trial was done in the United Kingdom, and the BBC actually did 2 programs on it because they really wanted to understand from the patient's perspective, from their family's perspective, as well as from the clinicians who were involved in enrolling and treating the patient what was going on. So I would recommend to anyone, you could download the episodes from the BBC. And what has inspired me is as I've gotten to know a number of these patients and their families, is that there's tremendous hope. And one of the most interesting aspects of hope is it actually propels forward ideas that even the best science is unable to do without others, in this case, patients and their families. So to answer your question, Scott, the effort that we initiated is now going to be taken up by a newly formed entity that's coming out of one of the charities in the United Kingdom. And so I'm an advisor to that group, and the hope is that we will repeat and actually do a better job at demonstrating the clinical benefit of the infused protein into the brain. And I know there's a lot of people that want to volunteer for this because I speak with them periodically. But when the clinical trial is completed, the hope would be that, in this case, the European Medicines Agency would then give it a registration so that it could be prescribed. This all takes time. You know, I've been involved in a number of clinical studies, and you'd wish that you could do them more quickly. My anticipation is that the design of this one will probably take between 2.5 and 3 years from start to finish to fully do all that's required in terms of enrollment, device implantation, delivery of the protein. There will need to be a control group. But I think the hope should be that, and this is really where the patients have inspired me, and it comes across in the BBC 2 series, is that they were absolutely convinced, particularly patients who did receive the drug, that it was making a huge difference. And as I've gotten my head around that, it makes clear that the alignment between the needs of a patient and their family with really highly capable and technically competent clinical investigation is the way to go forward. So I'm anticipating that within about a 3 to 4 year period, Scott, we will know for certain whether this idea that started so many years ago when we formed this, this little entity is actually going to make a difference. So I myself have hope, but I think what's inspired me in the last year is that so many people have called me, or we've Zoomed, or we've done, you know, big group meetings. One last summer where a lot of them flew over from the United Kingdom and beyond to meet with us. And it's spawned not only excitement, but now that there's a vehicle through which we can take this forward in what might be the last phase of clinical investigation, I am just really excited because I actually also believe that we made a good decision. And in the execution of this GDNF protein trial, it'll be important to make certain that everything that can be done to demonstrate clinical benefit will be done. And so that's my sort of role in being an advisor.
Yeah, thank you for that. Mark, let's talk about findneurohelp.org and your idea of setting up a perimeter of hope for families. Why don't you tell us about that? What does that mean?
Happy to do that, Ed. First, I want to tell Howard I'm fascinated by all of that. And I'm ready. Tell me where to sign up. I'm there.
Okay. I will connect you, Mark, for sure.
That'd be great. The perimeter of hope, that came up probably now, it's been about 4 or 5 years. We've had that service model in place, but it came as a result of individuals we spoke to, myself included, that explained what it was like when they went through the diagnosis process and then started having all these concerns that would keep them awake at night. It's getting hard to find restful, reparative sleep when you've got so many things on your mind. And I found personally that these concerns go in a sequential fashion, just around into like a perimeter. You create a perimeter. Top of the perimeter is mental health. And that's the first hurdle. You got to get to a place where you feel like there's hope, that you've got a full life ahead of you, that, yeah, sure, it's going to be some changes, but you just keep moving forward. And you got to get to a place where you can believe that. The second place is financial. You got to think, if you've got a neurological disease, about how long you can make an income. And so we have financial planners in our network that help individuals that get these diagnoses, help them with their finances. We have individuals that help with their estate planning. We have resources that will help with relocating and downsizing to a lower cost of living area. And then we, of course, we fund and support the universities for those students that are going into these specialty areas of neurology. And we will write a check for them. We did one for a student that was, I think it's postgrad at UC Irvine. And we helped him finish his project, and he was very thankful. And then we look at just trying to provide current information and resources to individuals about what's happening with their particular disease. People like Howard, we have resources where we can ask Howard a question about something that's been puzzling a patient. And so we can give them help from an academic standpoint. We've got probably 100 resources, 100 individuals in that category. So that's kind of what we do, but it all goes around and makes a perimeter. So it goes right around one to the next, to the next, to the next.
Well, it's like that logo behind you, like those hands helping, holding, reaching out. That's a beautiful thing.
We interrupt this broadcast to bring you a timely announcement.
Hi, I'm Sergey Gorbatov.
I'm Angela Lane.
Together we're researchers, writers and practitioners in the field of human resources.
And we've also been multi-country, multi-assignment career expats.
We owe our professional development and growth to a very large extent to the international assignment opportunities that we have had.
But in a world where distributed work may become the norm, we also want to understand what happened to the nature, duration, and purpose of international assignments.
Together with our colleague, Julian Dalzell from the University of South Carolina, we're undertaking a study on the future of expatriation.
And we'd value your contribution. You can participate in this important study by completing a simple 10-minute questionnaire.
Access the questionnaire by typing in your browser tinyurl.com/expert study. That's tinyurl.com/expert study. You can also find the link here on Ed's website next to this video.
Thank you for joining us in this study. In return for your contribution, we'll provide you with a copy of our research.
And of course, you'll be invited to an exclusive webinar hosted by Ed, where we will share our findings right here on Global Business News.
And so please go to tinyurl.com/expat study. Take the survey so that we can better understand the future of expatriation.
Something that's really neat is that the Bridge School partners with various organizations to provide learning for their students. For example, we partner with a major ballet company, and we are able to enroll several of their students into our school. So now not only is the student able to participate in a school and have a seamless transition while they're very active in their ballet career, but now they have other dancers that are with them that are doing some of the same courses. So it's almost becoming a camaraderie where they're taking similar courses, they're working together on their ballet, and really being able to form this great partnership with these organizations to provide a needed service. A lot of times there are student athletes who will spend hours and hours at the gym or at the basketball courts, wherever it is. And if they're attending a traditional school, they're in school from 8 to 3. They get a quick snack, and then they're at the gym for 3 to 4 hours in the evening. Coming to us and having that partnership, they're able to break that up throughout the day. They can have a morning practice, get some schooling in, have an afternoon practice, finish their schooling in the evening. So there's that flexibility. And additionally, if there are tournaments or performances, it's fantastic because if there's a week where they have shows straight through, they can take that week off of learning and then pick back up when they're done. So it offers this great flexibility. And for the program owners of these sports leagues, it is a win-win situation for them because they see this need. They see this need that their students need to make sure that they are obtaining the grades necessary to be successful adults in our country and in other countries. But it provides them an environment where they can be successful at both.
Scott, let's talk about, if I may ask you, about how the audience can get involved and find neuro help. Obviously, you can write a check, but what else?
Well, right now we're only accepting checks or we don't know.
No Bitcoin.
Our website, findneurohelp.org, has the ability for people if they'd like to help financially, whether they'd like to volunteer, but more importantly, if they find themselves in a situation with a neurological disease and they aren't sure where to go, they need the support and help. That's what we're here for. We have a designated a transitional support guide who's actually a social worker that'll actually be there as their advocate and help them through the steps that Mark talked about. And our objective is to really help them so that, for example, with someone with Parkinson's, that we can give them hope based on what Dr. Federoff is offering. And but in the meantime, while those things are still working their way through, that we have the ability to at least provide them support. So findneurohelp.org would be the place that someone would go. So that we can be of assistance to them and provide the support that they need so that they don't do it alone. We don't want them to do it alone. There's people there to help support. And I think, you put someone in contact with like a Dr. Federoff that realizes what he's doing and the efforts he's making to try to help people with Parkinson's, that in of itself brings hope. Just as he said, he's been encouraged by the patients and the families. We want to be able to do that also, with our perimeter of hope model.
So Dr. Federoff, I read in your bio the tremendous honors and research papers and acclamations. I'm from Boston, so I'm very familiar with Harvard Medical School area. I have some cousins I'm one of the only guys in my family that didn't go to Harvard. So I'm very familiar with it. And a long time ago, just aside, I was during the Vietnam era in Boston. I was in the Army Reserves. I was a medic, all right, but I was assigned to a thoracic surgical unit, and the doctors in charge all were in residence in Harvard. And I understand you did that at Mass General also.
Right.
And so we did our military duty for almost 6 years in hospitals, and I was trained as an OR tech, and I didn't go to NAM, but we did a lot of hospital duty at Walter Reed and in Boston Children's and Mass General. Very familiar with some of the science that goes into all of that. So when you were a student and in residency at Mass General and Harvard Medical School, did you ever imagine all this success and this progress with the neurological?
You know, I think all of us, notwithstanding the fact that we may have personal visions, you know, the practical issues about how to make a difference are really about every day and committing yourself, even though at times you don't make as much progress as perhaps you'd like. You have to continue to drive forward. You know, personally, I have always thought that when you do science, you have to ask the best question, but you also have to be prepared. When you have answered it, it may not necessarily have validated what might have been your principal hypothesis. You need to regroup, you need to move on. And if you stay attentive and you do that very rigorously, eventually, although it may be in a look back, you'll see that you've made progress. So my career, although it may be easy to look back and review a curriculum vitae and say, oh, look at all these things, you know, it's punctuated by things that would have been challenging and some failures. But I've always found that surrounding myself with like the best people, it's always about the human capital, has made it possible for us to think much more dynamically and comprehensively about a problem. And it's been a privilege to always have an opportunity to recruit those people to be around me. And the way that we have made success is really through inter and multidisciplinary work. You know, there's in almost every paper that I've published, there's a large number of co-authors. And it is the case that someone has to be the senior author, and more times than not, it would be me. But, you know, my first recognition is that this would have never happened without having just a great team. And being able to be part of that team and sometimes be the leader of that team has been really probably, as I think about my career, probably the greatest moments, because from time to time, you will make an observation that you would not have anticipated. And when prepared to understand the significance of that, you then are in a new space. And if you have the right people around you, you could move in a very concerted, orchestrated way to take on something that you didn't even know was going to be possible. And when it is in the service of patients, it's extraordinary.
So we're experiencing the miracle of the vaccines for COVID. Actually, it's working. Like, thank God. But can this same kind of warp speed production happen with neurological research?
Well, I think the story of Moderna and Pfizer, BioNTech is one about being prepared. There was an emerging technology that had been around for more than a decade, and the idea that really undergirds all of it is that you can introduce proteins into cells using synthetic RNA. And when the realization that could be the basis upon which one could immunize against those proteins, which are antigens, and they could come from a virus, such as a coronavirus, SARS-CoV-2, COVID-19, it allows for the great work that's been done in the past to all of a sudden arrive at a moment where nothing new has to happen. It just needs to be brought into clinical development. So it was the necessity of developing a vaccine rapidly. And as you know, we develop vaccines for many things annually, like influenza, hepatitis, sometimes even problems such as shingles or varicella infection. But the rapidity with which this came together was really because of great need. But then the detailed deployment of those new technologies that had been worked on for more than a decade in the service of actually making a new type of vaccine. The fact that it worked as well as it did, now it was clear that it requires both a prime, a first vaccine, and then a boost. So all of us who have received the Pfizer or the Moderna have received 2 vaccines. Right. That tells us about the immune system. But to your question, Ed, I think that there is a lot poised to have an impact on neurologic disease. And while it won't be strictly the way that the Moderna or Pfizer-BioNTech story came together, I think there is a sense of urgency that we all experience. Some of the diseases that we've touched on today are associated with aging. There is this silver tsunami, as I'd like to refer to it globally, where more and more people are living longer because they haven't gotten heart disease or they haven't gotten cancer. And so neurologic disease is growing in prevalence. And so I think the urgency is, while not as much as one might have contemplated as we've experienced with the pandemic, but there is an urgency. And I think that there is technologies that are in, if you will, the waiting to be deployed clinically. So it would be just an incredible opportunity over the course of the next half a decade, with that urgency priming the need to move things into clinical development, is to make really great decisions about what will be evaluated. Because every time you ask a patient, would you be a research participant, you're asking a lot of them. And if you're the scientist, the clinician, you have to have confidence that the question you're asking them is one that will require sometimes the very first administration of a drug that's never been delivered to anyone. And so the confidence that you have in the science that really underpins why this might work has to be part of that discussion. And as I said earlier, I've been inspired by patients all along the way, but when they agree, knowing that early in clinical development, first in human, there may be no benefit to them, it is an incredible thing for them to have come to the yes, recognizing that, well, it may not benefit me, but the science is so seemingly powerful. How can I help bring this to the next level? And one way to do that is to be a research subject participant. So we've experienced something that rarely happens in clinical medicine. We had a scourge that was global. It really did inspire people to think and really be more distensible in terms of taking technologies that had been initially developed, as was Moderna, for a different purpose, and push it forward quickly, but also very safely and responsibly. And I would say the other thing, which is very impressive, is that the orchestration on the regulatory side, although it may be still frustrating for people to look back and say, why didn't the FDA do this, that, or the other earlier? Well, this has been done at light speed relative to the way things normally go. And I think it was a really good example of orchestration between those who hold the responsibility about saying, yes, you can have an emergency use authorization, an EUA, for a whole variety of tests, and then ultimately vaccines. What we've witnessed can be replicated. I'll just tell you in two minutes, I've been approached by a foundation about 4 or 5 months ago to see whether I would help them realize what I call the acceleration of science. It's not about developing new biological insights. The science is there. And what I said to the head of the foundation, if I were you, I would think about the construct being, how can you facilitate putting the gas pedal all the way down and sustaining it so that you can go as fast as you can responsibly, with the resources being deployed in a manner that you can track them and you can put points, if you will, on the board. And if you do that safely, what at that point was just the early emergence of the Moderna and the Pfizer-BioNTech vaccines, you can apply it in almost every area of clinical disease. And so they're gonna come back to me. They want me to work with them to try to put that, if you will, it's sort of a broad idea, but it needs to be really reframed. But they have access to enormous amounts of capital through a variety of networks. And I'd love for neurologic disease, as I expressed to them, to be one such example of where you need to basically go into, if you will, hyperdrive acceleration.
So I've had the Moderna twice with no side effects other than after the booster, we were really tired, but a good night's rest ended all that. It was no problem at all. But a lot has to do with just talk about me, immune system being okay, strong. I eat my green beans and asparagus, so, but a lot of people don't. And so maybe, I don't know, maybe the lack of a strong immune system brought on a stronger reaction in some people to some of the shots. What do you think about that? Is it just too wild to think about?
No, I actually think we know a few things about aging and immunity. Typically, as people get older, the robustness of a response to a foreign infection, whether it's a virus or a bacteria, tends to be diminished as you get older. There is effectively some type of immunosenescence that goes on with aging. People who tend to be in better shape, who pay more attention to what I would call the attributes of a healthy lifestyle, they are often able to have a sustaining of an immune response that would have been more like would have occurred earlier in life. The second point, which I think is now becoming a little bit more clear, is that the nature of the prime and the boost reaction are very different depending upon the person and their underlying medical condition. And I haven't seen a complete cataloging of that yet published, but my impression is, from talking and reading papers about sort of what would be case series and some of the clinical trials that have been published, it would appear that older people who don't take care of themselves may not have the best immunization, whether it's the prime or the boost. And some of the side effects are relatively modest, but there have been some that have been a little bit more, and these are the ones that tend to be over-reported, are quite adverse. So I think what we've learned generally, Ed, is that this new technology is incredibly fast to bring to market. It can be manufactured very safely. It can be delivered safely. And it would not surprise me. I'll make two predictions. One is I think we're going to have annual coronavirus vaccines that will be tightly coupled to whatever is the variant du jour or presenting and spreading. But I think this technology may lend itself to other vaccines. And particularly if there were, and I suspect there is interest in figuring out, because the way we typically make influenza vaccines, we have to pick what are the emerging strains often before they're actually here. And if you look back at the last 3 or 4 years, the inclusion of whatever strains into the influenza vaccine was only producing about 50 to 60% coverage. And although I've always recommended to patients that you should get annual vaccination, it's frustrating when they get a real infection because the vaccine didn't cover whatever the particular variant or strain that unfortunately they were exposed to. But I think this whole issue about this general approach is going to revolutionize the way we do some things as it relates to vaccine biology. But it wouldn't surprise me if it will also have impact in other diseases, including neurologic disease. And so I think synthetic mRNA is going to be a big deal. And I really didn't come prepared to talk to you about what my company does. But that is, in fact, the reason I took this position, because I think that it's there. It's the new thing.
So I want you to come back. Please come back and give us another lesson. All right, real quick, because I know the time is short. You mentioned the synthetic, the development of a synthetic for like Moderna or the other one. The synthetic what? A synthetic disease or a synthetic something that doesn't upset my system?
Right. So the notion is really derived from really the normal human biology. Cells need to make proteins. And the way that they make proteins is they have the DNA copied into a more transient informational molecule called RNA, ribonucleic acid. And the particular ribonucleic acid that is geared to make protein is called messenger RNA. Synthetic RNA, particularly of the mRNA type, actually takes advantage of understanding how to produce a more efficient mRNA than the cell itself would make. And in doing so, you can drive expression to levels that would be higher than would be the case with just a normal version of that same messenger RNA. And that effectively is what these new technologies are about. You have to get them into cells. And so that was another part of both vaccine development programs. And so they've used some new technology there. But the idea that you can take a synthetic made chemically in a laboratory under manufacturing conditions that are safe for human use, you can encapsulate it and inject it into the muscle, as all of us have had vaccines, and then allow for that to get into cells, then synthesize, in this case, the spike protein from the coronavirus that then sets off the endogenous, the person's immune response to recognize it. And then you put into play, there's a set of events to get the immune system revved up. And when you come back in with the boost, you then have this massive expansion of that immunological set of events started with the prime, the first vaccine, that actually causes the sustained immunity that we're hopefully going to find out will last maybe as much as a year and beyond.
Well, I'm ready for the booster in the fall. They're talking about November or December here at in Coronado Sharp Hospital here. But what I just want to ask is, what causes a variant? Is it just like a life form that just gets some impetus and develops?
Well, within the, let's just be specific, within the world of viruses, variants arise because when those viruses replicate in hosts, there is a certain amount of sloppiness as it relates to the fidelity with which the original nucleic acid that encodes all of the viral machinery is replicated. So when there is a change, that change could be recognized as a variant. And if the variant is one that makes the virus, once it's come out of the cell, either more virulent, meaning that it can produce a level of infection that is more worrisome, or perhaps even one that can be more easily transmitted from person to person, you now have a likely emergence of a new virus that will be even more effective than the original one with respect to how it engages with effectively us being the hosts. Finally, variants occur within our own body. When we have cells that undergo replication, there is a small degree of error associated with replication. Usually when DNA replication occurs, if there is a substantial change in the DNA code, those variants typically, if they are favored to divide and to continue to expand, they might become the first cancer cell. And so it's that type of somatic mutation that occurs to create variants that arise in the body. And sometimes our immune system is able to recognize them before they become a cancer and they get deleted. But if they're successful, as some of these variants are, they then become neoplastic clones, which have figured out how to evade or partially evade the immune system. And then they become the basis upon the patient developing a new cancer diagnosis.
So I know that's heavy science. Thank you for that, though. So in coming shows, we're going to do this kind of a show with other doctors and research scientists, one a month, and we certainly want you to come back. One last thing. It's been reported that the flu this past season didn't disappear, but far less impact. Did this the vaccines for COVID have something to do with that?
I think the best explanation is that people were staying inside. So they were socially distanced from one another. Flu spreads throughout the community. It's a respiratory virus. So when one has less chance of exposure, there's less chance of infection. So there was a derivative benefit, although none of us would like to think about replicating a pandemic where viruses that otherwise would take advantage of people gathering, in the fall and in the winter and having the close contacts that allow influenza to spread by virtue of the roughly, 18 to 20 months of basically staying at home, probably made the flu far less effective because it didn't have the opportunity to really get into the community the way it would have otherwise in a normal year.
Thank you, Dr. Federoff. This has been a wonderful education. Mark, do you want to sum up?
Boy, do we have another hour?
All right, let's talk about your golf tournament.
Thank you so much today. It was great. Thank you again, Howard. Howard's got kind of a humble brilliance about him. I've always liked Howard because he puts his ego at the doorstep, as brilliant as he is, and he can rethink things. He doesn't get entrenched in his thinking, so he's able to rethink and really redirect. And I think he'll be one of the key people that's gonna help us in our challenges. The tournament's is going to be September 27th. It's our 4th annual tournament, so we're excited. Each year it's grown. We average probably about 85 to 90 players. We're hoping to break the 100 mark this year, but we haven't done that yet. But we're going in the right direction. And it's going to be at Yorba Linda Country Club, a 10 a.m. shotgun start. For those of you who are golfers, you know what that means. And it's going to be a lot of fun, Ed. It's going to be a lot of fun. We've enjoyed this so much.
I'm going to come.
Oh, great. Yeah. Wonderful. Are you going to
play? Yeah, but I'm not going to win anything. So.
I'll try and get you foursome because I've got 2 ringers. So.
Yeah.
And I just want to let you know, we truly, Find Neuro Help has been very appreciative of Dr. Federoff and his support for us and what we've done. He's been with us for many years in the sense of being a support to us and giving us ideas and advice and counsel. And we're truly appreciative of him and what he's done to help us and his support that he has given us with Find Neuro Help. And so I just wanted to thank you, Doctor, for what you've done in helping us and being there and being, a friend to us and being a friend to Find Neuro Help. And I just wanted to thank you.
It's my pleasure, Scott. Certainly, Mark and Ed, to be with you and to continue to support the great work that you're doing.
Thank you, Dr. Howard J. Federoff. This has been a brilliant education for me, and I think for our audience out there. Mark, findneurohelp.org needs volunteers, right?
Oh, yeah. Take as many as we can get.
Great. Okay, well, thank you. Our next program will be in about 30 days, so stay tuned. Thank you for
Thank
being
you.
on Global TV Talk Show. Really appreciate you all.
Thank you, everyone.
Ed, thank you
you.
very much. Thanks, Doctor. Appreciate it.
My pleasure. Take care, everyone.
Thank you, and good luck to you, Doctor.
Thank you.
Thanks.
Thank you for joining us in the meeting room at Global TV Talk Show.
Have a wonderful day, and stay safe.